Yeah, so every April, the U.S. Environmental Protection Agency puts together a greenhouse gas emission inventory, which looks at all sources of greenhouse gases and sinks, so meaning places where greenhouse gases or particularly carbon dioxide get taken up in the U.S. economy. So that includes everything from transportation to agriculture that's accounted for. So the most important greenhouse gas, the one that contributes the most to U.S. emissions, is carbon dioxide. The second most important is methane, and the third most important is nitrous oxide. So these three gases, they have different properties, or basically abilities to trap heat in the Earth's atmosphere, and they have different lifetimes, how long they stick around in the atmosphere. So typically, to take that into account, and what the EPA inventory does is corrects for those two factors with a system called Global Warming Potential 100. And so these different gases have different values, and they're all referred back to carbon dioxide or CO2, which is the reference gas. So in that system, methane has a global warming potential of 28, which means it's 28 times more potent. So you can think of this as basically 1 pound of methane emission is equal to 28 pounds of carbon dioxide or CO2. If we think about the emissions inventory, and agriculture is roughly 10% of greenhouse gas emissions, animal agriculture directly is about 4.5% of US greenhouse gas emissions. And so when we think about that big chunk of 4% of emissions, most of it is actually enteric methane, which is the methane that's naturally produced from cattle. So AgNext is really well positioned to help try to measure and mitigate enteric methane emissions because of our unique facilities and the people that we have involved at AgNext. So we have climate smart research pens where we have the ability to measure 180 plus animals of enteric methane emissions every single day. That allows us to look at ways to mitigate methane emissions in a production environment, allows us to think about scaling these solutions, and the human side of AgNext, the people that we have on the team, we have folks with disciplines from animal science, beef and dairy, but also modeling and in economics and ecology, right? So all those different pieces together allow us to look at solutions and think about their cost-benefit analysis, to think about how we could quantify and scale those solutions and account for their impacts at a large scale with a modeling expertise. So that allows us to have that positive feedback loop, if you will, of all the different people involved in the process and the research capabilities to really answer these hard questions.